Hi, welcome to Geometry 2.6 Proving Angles Congruent. Our objective is to prove and apply theorems about angles. In this section, we're going to learn about theorems and we're going to learn how to prove things about angles using a variety of methods. We've already discussed the relationship of vertical angles. We can easily prove this relationship is always true using deductive reasoning. A theorem is a conjecture or statement that you can prove is true. So it's essential to your understanding that you can use information, definitions, properties, postulates, and previously proven theorems as reasons in proofs. We've discussed this before, this theorem 2.1, the vertical angles theorem, and it's that all vertical angles are congruent. In this picture, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Angle 1 and angle 3 are vertical angles, and angle 2 and 4 are vertical angles. Vertical angles are formed by two intersecting lines, and you might remember that they meet kind of like a V and an upside down V, or in the case of 1 and 3 it's like a left and a right V, vertical angles. So we discussed this theorem back in chapter 1, but it's officially introduced here in this chapter, in this section. Please write this down on your note template. Vertical angles are congruent. We're going to prove this in class on Monday. We're going to use the vertical angle theorem. We've done some practice in class together. Because we know that these two angles are vertical angles because they're formed by two intersecting lines, then we know that they are congruent using the vertical angle theorem. And therefore, we can set them equal to one another. We can say that 3x is equal to 2x plus 40. So to find the value of x, we would isolate this variable. We would collect all of our x's on one side by subtracting 2x from each side to find that x is equal to 40. Knowing what the value of x is, we can then substitute it in to find the measure of each of these angles. If this angle is 3 times x, 3 times 40 would be 120 degrees. We know these are vertical angles, so we know that they should come out congruent. We could substitute in the value of x for the lower angle. 2 times x, 2 times 40 is 80, plus 40 is 120. Vertical angles are congruent. Knowing what we do about these angles, then we can also say these angles are vertical angles and they are congruent. Do you know what the measure of each of these would be? They would each be 60. Because these angles lie on a straight line together, they're a linear pair. They are supplementary. And they are congruent. Theorem 2.2, the congruent supplements theorem. We did an investigation of this theorem on Friday in class, and we're going to prove this theorem on Monday in class. Please write down the words and draw the pictures. If two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So in this picture, angle 3 and angle 1 are supplements. They're supplementary. That means their sum is 180 degrees. Also, angle 2 and angle 3 are supplementary. So if angle 1 is supplementary to angle 3 and angle 2 is supplementary to angle 3, then that means angle 1 and 2 must be the same measure. Let's take a look at this by plugging in some numbers. Hypothetically speaking, if I say that angle 3 is 120 degrees, and I know it's supplementary to 1, that would mean that angle 1 must be 60 degrees, because 120 and 60 is 180. if I know that angle 3 is supplementary to angle 2? If angle 3 is 120 degrees, then what's the measure of angle 2? 180 minus 120, angle 2 would be 60 degrees. Therefore, angle 1 and angle 2 are congruent to each other because they're both supplementary to the same angle. Congruent supplements theorem. Likewise, we have the congruent complements theorem. It's along the same ideas as the congruent supplements theorem. If two angles are complements, remember complements, that means 90 degrees, right? Of the same angle, or of congruent angles, then the two angles are congruent. So let's look at this. If angle 1 and angle 2 are complements, and angle 3 and angle 2 are complements, then that must mean angle 1 is congruent to angle 3. Let's put in some hypothetical numbers here. Let's say, for instance, angle 2 is 60 degrees. If angle 2 is 60 degrees, and angle 1 and angle 2 are complements, then that means together their sum is 90. So 90 minus 60, that must mean that angle 1 is 30 degrees. And if angle 3 and angle 2 are complements, if angle 2 is 60 degrees, then that must mean 90 minus 60 is 30. Angle 3 is also 30. Therefore, angle 1 is congruent to angle 3. And again, we're going to write a proof of this on Monday in class. The next theorem that we have, again, it's something that we can easily prove. It's pretty common sense. This one's called the right angle congruence theorem, and it states all right angles are congruent. Why? The definition of a right angle is an angle that measures 90 degrees. So if angle 1 and angle 2 are right angles, that means that they are both 90 degrees. And remember, that's what that little box there represents, a 90-degree angle. And if the measure of angle 1 is equal to the measure of angle 2, then we know angle 1 is congruent to angle 2 by the definition of congruence. So all right angles are congruent? That's because all right angles equal 90 degrees. And if they all equal 90 degrees, then they're all equal to each other, and therefore they're all congruent to each other. The right angle congruence theorem. The last theorem we're going to discuss has to do with the right angle congruence theorem. And this is a theorem that says if two angles are congruent and supplementary, then each is a right angle. And that's because if they are supplementary, then that means their sum is 180 degrees. And if they are congruent, that means they're equal to each other. And there's only one way to divide 180 equally, and it would be to get 90. So, if angle 1 is congruent to angle 2, and you know 1 and 2 are supplements, that means they have a sum of 180, then you know each of them is 90. And if they are each 90, then you know that they're congruent to each other because of the right angle congruence theorem. This theorem doesn't have a name, but we can use this theorem, this logic, to help us to prove that two angles are congruent because of the right angle congruence theorem. So before we end tonight's lesson, let's apply some of the things that you've learned. What are the measures of angles 1, 2, and 3 in the picture below? Think about it for a minute. Try to determine if you can find those measures. You're given that this angle is a right angle, so it's 90 degrees. This angle here is 40 and the one next to it is 50 degrees. Angle 1 is a vertical angle to this angle. So angle 1 would equal 90 degrees. Because of the vertical angle theorem, they're congruent, and therefore they're equal. Can you figure out what angle 2 and angle 3 are? Angle 3 is vertical to which angle? So the measure of angle 3 would be congruent to its vertical angle. So it would be 40 degrees. And then lastly, angle 2. Angle 2 is vertical to the 50-degree angle. So it's 50 degrees. Did you figure those out before I showed you? Take a look at this one. See if you can find what is the value of x. First determine what's the relationship between these two angles. Establish your equation and determine the value of x. Pause the video and take a minute to try. So I know these angles are vertical angles. Vertical angles are congruent. So 6x plus 16 equals 136. So you want to isolate the variable. Subtract 16 from each side. So 6x is equal to 136 minus 16 is 120. Now you would isolate the variable by using the division property to find that x equals 20. So your answer is B, 20. Did you get that before I did? Great job. Last one. Name all pairs of congruent angles in the figure and justify your answer. Justify means you're going to provide the reason, just like we've been doing in proofs. So pause the video, take a minute, and name all pairs of congruent angles in this figure. And then say why are they congruent? How do you know? When you've finished, unpause the video and see if you got it right. So these are vertical angles. Angle AOB would be congruent to angle COD because they're vertical angles. So we would use the vertical angle theorem. Also, angle AOD is congruent to angle COB because of the vertical angle theorem. You could also say that you know angle AOB is congruent to angle COD because they are both supplementary to this angle. They are congruent because they're both supplementary to angle BOC. They lay on a straight line with it. Angle AOB and angle BOC are supplements. They are 180. And angle BOC and angle COD are supplementary, and therefore they together equal 180. So you could have said, by the congruent supplements theorem, you know that they are supplementary. And that would also be true. Could you say the same thing about the other pair? AOD and COB. Are they both supplementary to the same angle? They are, right? They're both supplementary. AOD is supplementary to AOB, and BOC is supplementary to AOB. So therefore they could be congruent. Or you could also say they're both supplementary to COD. Isn't that true? They form a straight line. So these two are supplementary. Or these two form a straight line. So they are supplementary. And therefore you know these angles are congruent. So either way you could have proved it. We're going to prove these theorems tomorrow in class. Great job if you got all these right. See you tomorrow. Have a great day.